So you did not send me those numericals.
No, actually I didn't solve it. That's why I have to send both of you. Chapter number 5. Electrical electric resistance and Ohm's law. Electric resistance and Ohm's law. First we'll see what is current, then potential, then Ohm's law, then resistance, then few more factors. In your lower standard, you might have studied what is current.
So when did we do chapter 4?
Pardon?
We haven't done the chapter 4.
Aware, we have done all the chapters, only we have not gone as per your book. Now, what I am going to do, I am doing first fresh chapter to avoid your confusion.
Sir, you're barely audible.
Hello? Now I'm audible.
Yeah.
I'm starting with fresh chapter to avoid your confusion so that you understand everything properly. That chapter also we have done. Dielectric we did, polarization we have done. Now what I will do.
We haven't done that, sir.
So let it be, we'll do later on. But right now I'm doing this current chapter because I have to revise this full electrostatic for you from beginning. So as from the test, I will come to know how you are understanding these chapters. Sunday it will be test whatever I complete today and Saturday's lecture. It may be 10 mark test, 15 marks test, 25 marks test, depending upon how much I complete the topic. And then I will prepare proper notes for that chapters, and then I will discuss with you all so that you are not having any tension or any confusion in the mind. Current.
The sums you are going to solve and give us
that I will give. It takes time. 30 sums it takes time to solve.
And also the papers recorrected.
Forget about anything. This is today's start. From here you have to start. Rest all I will keep on explaining as per my comfort zone, and after I prepare the notes, so that I want to for you to avoid confusion. Chapter number 5. Current. Any exam is kept in the school or college? Any exam they have kept?
It's in July right now.
July. Okay. Topics you know?
No.
Not yet? Okay. So we'll start with this chapter. You don't be bothered about that. I will prepare first because I feel somewhat you are confused. No? So I want to avoid that confusion. Because if confusion is there, you will not understand the things. So we'll start with first chapter. And that electrostatic, I will start again from the beginning. Required things I will keep on explaining. Current. The rate of flow, because one more batch I have. When I start in that, then I will record all these lectures so that I will send you and then I will explain. The rate of flow of charge. Which charge? Positive or negative? When we say current is rate of flow of charge, which charge? Positive or negative? Hello? Rate of flow of charge is called current. So do you know which charge? Positive or negative or any charge?
Negative.
Okay. What about you, Puran?
Any.
It can be any charge. Only the difference will be in the direction. If it is negative charge, then current will be flowing opposite to that charge. If it is positive, then current will be flowing in the same direction. So whichever charge flows, we say it is current. So rate of flow of charge is called as current. It is scalar quantity or vector quantity? It is scalar quantity. What is its SI unit?
Coulomb.
SI unit is coulomb.
Oh, that's charge. Wait, I'm confused. Current is ampere.
So its SI unit is coulomb per second or ampere, denoted by A. Write this much. The rate of flow of charge is called as current. It is scalar quantity. Its SI unit is coulomb upon second or ampere. It is given by I equals to Q upon T.
So you're going to give us notes, right?
Whatever you are writing, that itself is notes.
You said you were going to give notes.
No, I didn't say. When I told I will be giving you numerical solution, which actually I have to solve and send.
You said that you'll do this chapter and then there will be a 10, 15 or 25 mark test, and then the next week you will give us notes for it so that there's no confusion.
See, first of all, this is what you are studying. Do you forget about what is done? You start from this. Because many times you speak more but you grasp less. I told I will be giving you the notes and then I will, but that chapter I will not ask. This chapter I will do. Those chapter first I will give you notes, then I will teach, because already I have given you notes. So if it is given, I will say refer this. Whatever you are writing, that itself is note now. Notes is what? Only it is not typed. While writing also, you should start remembering now, because you have less time to practice all this, since you are having so many other work. Completed?
Yeah.
The rate of flow of charge is called current. It is scalar quantity. SI unit is coulomb per second or ampere. It is given by I equals to Q by T. Do you know what is 1 ampere defined as? Any of you know what is 1 ampere defined as? Since I is Q by T, so 1 ampere is 1 coulomb upon 1 second. So we say when charge of 1 coulomb flows through conductor for 1 second, then current is said to be 1 ampere. Right, definition of 1 ampere. When charge of 1 coulomb flows through conductor for 1 second, then current is said to be 1 ampere. If done, then tell fast, so that we can move ahead.
Yeah, done.
Okay. Next one. How many electrons flowing for 1 second produces current of 1 ampere? Favorite question for 1 mark. How many electrons flowing for 1 second produces current of 1 ampere? Since I is Q upon T, so 1 ampere current is suppose n electron, so Q will be Ne, time is 1 second. Charge is total number of electron flowing. We want how many electrons? So n. From this n will become 1 upon E, where E is charge of electron 1.6 into 10 raised to minus 19. That is 10 upon 16 into 10 raised to 19. I removed one decimal from denominator. That is 100 upon 16 into 10 raised to 18. 16 into 6 is 96. Remainder will be 4. 16 into 2 is 32. Remainder will be 8. 16 into 5, 80. So 6.25 into 10 raised to 18 electrons when flow, then we get current of 1 ampere in 1 second. Copy.
The answer.
Okay. Next, define current density. Whenever word density comes, it can be either per unit volume or it can be per unit area. So current density is defined as the current flowing per unit cross-sectional area. Cross-sectional area means perpendicular to the, suppose this is conductor and this is current flowing. So if I cut it perpendicular to the direction of current, then this area is called cross-sectional area. So current flowing per unit cross-sectional area of conductor is called as current density. It is given by J bar equals to I upon A bar. That means it is a vector quantity. Its SI unit is ampere per meter square. Right. Hello? Yeah. Good evening. Farhan say, I am having a continuous lecture. Whenever I require some help, I will call you. Written?
Yeah.
Can you suggest me what will be dimension of this current density? If you are remembering from 11th, how we write dimension? Once they had asked in exam. In dimension, whenever you see length, meter, centimeter, we write L. If we see kilogram, gram, mass, we write M. When it is time, second, we write T. When it is temperature, Kelvin, we write K. If it is current, ampere, we write A. This is the rule. So we have seen here I upon area. Area means meter square. So when I see I, what I will write in dimension? I means current. When we see current or unit ampere, then what we write in dimension? When we see current,
Coulomb per second.
what you said?
Coulomb per second, right?
Coulomb per second is
For current, right? Oh, sorry. Yeah.
first listen. Have you heard about dimension? Otherwise, if you don't know, you'll go wrong.
Yeah, I know the dimension. I was just saying the SI unit for current.
SI unit of current, just now we wrote Coulomb upon second or ampere.
Yeah, that's what okay.
First, do you know what is dimension? If you are not knowing, you'll give wrong answer. No? Are you knowing what is meaning of dimension or how to find dimension?
Yeah.
If you don't know, then I have to explain. If you know, then I can go ahead.
Yeah, I know.
What is dimension of area? Dimension of area?
L2
L2.
or M0 L2. Yeah.
L2, and generally we write as M0 L2 T0. Not present means raised to 0. So generally we write as a rule answer in MLT. Not present will write 0. What is dimension of force?
M1 L1 T minus 2.
M1 L1 T minus 2. Perfectly right. See, either you know this or we will found if we don't. So if I don't remember, I will say force is mass into acceleration. And when I see mass, I write in dimension m raised to 1. Acceleration, I'm thinking of its unit. It is meter per second square. So meter means L1, time is t, per second square is minus 2, which I will write m1 L1 t minus 2. So there is one rule. You try to convert that formula in terms of fundamental quantity, so that when you see mass, you write m, when you see length, you write L, when you see time, you write t, when you see temperature, then you write K, when you see current, you write A. Or in unit, when you see kg or centimeter, you write M, kg or gram, you write M. When you see meter or centimeter, you write L. When you see second, you write T. When you see Kelvin, you write K. When you see ampere, you write A. This is the rule. So here it was I upon A. A is area. So when I see I will write A1. When I see area, it is L raised to 2. So that means we can write dimension is in standard form M0 L2 T0 A1. So its dimension is, sometimes they will give only A1 L2. Sometimes they will give M0 L2 T0 A1. So its dimension is this. That is same as M0 L2 T0 A1. Right. This was asked once in the exam. In metals, electrons produce current. When we say electron, we are talking about free electrons which are loosely bound with the nucleus. So in metal, electrons produces current. The motion of electron produces current. To be more precise. In electrolytes, that means liquid through which currents can be passed. Liquids or gases, both positive and negative ions produces current. That means if electron is going to the right side and positive ion is moving towards left side, if both are same in number, current is not zero. Common mistake we say electron on the right, positive ion on the left, net charge 0. No. Electron will give current opposite to its flow. That means in the left. And this positive ion on the left will give current in the left only. So both in same direction, current will be algebraic sum of current due to flow of electron and due to positive hole. These electron and positive ions, they are in opposite direction. But current will be in same direction, that is in the direction of positive charge. So if they say electrons and positive ions both are traveling in same direction and they are equal in number, then what is current? Then I will say 0. Because electrons current will be opposite and positive will be in the same direction, net will become 0. So you have to remember every time, current due to positive is in same direction, due to electron is in opposite. So if both are traveling in opposite direction, like electron to the right, then its current is to the left. Positive to the left, current is to the left. Left, left, we will add. So net current will be sum of current due to flow of electron and due to flow of ions in case of electrolyte. Right? Note point 1 and 2.
Done.
In case of chemistry, have you studied chapter called kinetic theory of gases? In chemistry you have done kinetic theory of gas?
I don't think we have done it yet.
Okay. But in 10th you might have studied, if this is conductor, it contains what? If this is conductor,
Electrons.
large number of free electrons. Where they move? In right or left direction, those electrons?
Both. I'm not sure.
They are in the state of random motion. That
Yeah.
means they move in all direction like gas. So free electron I can consider like gas molecules. They are in the state of random motion, moving everywhere. So net flow in any one direction is zero. Net flow in one direction is zero. Therefore, we say there is no current in the conductor. Because if 10 electron moves to the right, 10 will move to the left, net will become zero. So that means without connecting some cell across this, they will not give any current. Losing of electron is called as what? Losing of electron is called as what? Positive charge.
Yeah.
So that means when this electron moves away, it leaves fixed positive ions here. They are not in motion, they are just fixed from wherever electron comes out. They are fixed positive ions. When we connect a battery across this, now these electrons will be attracted towards positive terminal of the battery. They will try to align themselves towards positive terminal of the battery. So now earlier they were in random motion. Now they will try to align themselves in one particular motion, that is towards positive terminal of battery. During this motion, the fixed ions, they are not moving. So these electrons, will they collide with them during their motion? This is one electron, started from here, somewhere there is fixed ion in between. So this is like our toll plaza. This is like toll plaza. So I'm traveling from Mumbai to Ahmedabad. I don't know how many toll plazas will come. But when it comes, I have to stop. If I stop here, then some money is given to them. Or if there is e-pass, they will scan that and then I'm allowed to move ahead again. Again, there will be some toll plaza. So again, I have to stop. Again, it will come. So there is frequent collision with this fixed ion. Those are taking my energy, that means my money. And this battery is constantly supplying me energy. So during my two toll plaza, there is some distance covered. Some distance covered. Here I will say electrons, when they collide with fixed ion, before next collision, they are covering some distance. So this distance covered between successive collision by fixed ions, it is called as free path. Distance covered by electron during successive collision is called as free path. And average of large number of free path is called as mean free path. So here we have to study three terms. One is called mean free path, other is called relaxation time, third is called as drift speed, then relation between them. Define first mean free path. Same you might have studied last year in chapter called kinetic theory of gases. Even it was there in physics. Gas molecule collide with wall of container. Distance covered between successive collision is called free path. Here we will say the meaning followed. What is free path? Before they collide, they are freely moving. So between successive collision, they are free. That distance covered is called free path, and average of all these distances is called mean free path. The average distance, moved, you can say covered, one in the same, average distance moved by free electrons in successive collisions with fixed positive ions is called as mean free path. Let lambda 1, lambda 2 up to lambda n be free path during n collisions. Therefore, mean free path denoted by lambda bar is lambda 1 plus lambda 2 up to lambda n divided by n. Copy mean free path definition. सरोज ये कवा आ जाना सुबह उड़ जाएगा ना बेचारा उड़ गया दे दो उधर रख दो ले लेगा
Done, sir.
Second, relaxation time. Relaxation time. It is usually denoted by this letter called, we read as tau. Relaxation. This is conductor, and there are fixed positive ions here throughout conductor, because free electron means it has left the positive ions. When we connect battery, electrons which were randomly oriented will move in the straight line, and then it may collide with this ion. When it collides, then battery gives the energy, that because we know E is potential upon distance and force upon charge is field, so it gets force EE, this electron. Due to this force, again it gets energy and start moving. Again some positive ion will be in the path, it will collide. Again it will either change the direction of the motion or travel in same direction, but again collide. So before it is colliding, it is relaxed. That means no tension at all, unless until some ion obstructs the path. So between two successive collision, the electrons are relaxed, means they are moving without any tension, without any collision, without any obstruction. This time taken is called as relaxation time, because they move like this also. I don't know how they are moving. Finally, it will come outside. So inside they collide, then they turn the path, collide with other, and finally comes out. So between successive collision, the time interval is called as relaxation time. Generally, we don't take time only for one collision, but we'll take total relaxation time as average time interval between successive collision. So the average of time intervals between successive collisions of free electrons is called as relaxation time. If tau 1, tau 2 up to tau n are time between n collisions, then relaxation time is taken as average of all these time intervals. Then relaxation time comma tau is equals to tau 1 plus tau 2 up to tau n divided by n. Now complete this definition. we get?
Yeah, sir.
Third one, drift velocity. Drift velocity. See, electrons which are moving in the absence of electric field or potential, they are removed from the orbit due to thermal agitation. So, due to thermal agitation, velocity of electron is in the order of 10 raised to 5 to 10 raised to 6 meter per second, randomly moving inside. But when you connect battery, then same electrons, they try to align themselves in the direction of field. What's the positive term? That means if I consider one electron like this, it is moving towards positive fixed ion. It started moving in this direction because that battery is supplying them energy in the form of force, which we know force upon charge is electric field, and electric field is potential upon length of conductor. So each electron gets force EE. That means it gets acceleration by using Newton's second law, EE upon m. So this acceleration changes either magnitude of velocity or direction. So when it starts from some point A, it collides with the other one, now comes to rest. That means velocity at the point of collision will be momentarily zero. Again gets energy, again starts moving. Again, if collides, its velocity will become zero, and again it will start. That means at every collision, it is coming to rest. This shows that its velocity is not constantly increasing. Otherwise, you will feel that its velocity should become more than what it was earlier. So due to this, getting energy, collision, rest, again getting energy, collision, rest. Finally, when they emerge out from the conductor, their velocity is very small, in the order of 10 raised to 4 meter per second. This average velocity by which electrons are coming out is called as drift velocity. That means they are not moving in a straight line and getting pushed directly. They are having collision, again moving, again collision, again moving, and then coming out. That type of motion is called drifting. If this is river water, here suppose we have one piece of leaf, then due to river current, it will keep on flowing like this. Somebody comes, it will collide, change the direction, again keep on moving. That means it is not constantly moving in a straight line. It gets collided, again changes the direction, again moves. Such type of motion is called drifting. And this velocity by which they emerge out is called drift velocity. It is very small, in the order of 10 raised to -4 meter per second. Only possible when battery is connected to a conductor. Otherwise, they will not come out. So velocity, when they are moving inside, in the absence of battery, that velocity is velocity due to thermal agitation of electron. Order is 10 raised to 5 to 10 raised to 6. I will give you a note. Drift is very small, 10 raised to -4 meter per second. So the average velocity with which electrons are drifted out of conductor when electric field, that means potential difference, electric field is applied across conductor is called as drift velocity. It is in the order of 10 raised to minus 4 meter per second. Right. Generally, we feel it is very large. No, it is small because it is colliding in between. Right, drift velocity. Then we will derive formula. Yes, completed.
Yeah.
Derive expression for drift velocity. Derive expression for drift velocity. Just wait, let me complete full, then you copy. Consider n free electrons of charge E present inside a conductor. Consider n free electrons of charge E present inside a conductor. When electric field E is applied across conductor of length L due to potential difference V, then each electrons gets accelerated towards positive terminal of battery by force, comma, F equal to ma, E equal to ma, A equals to E upon m. Just copy this much. We are interested in final velocity by which it will come out. Initial velocity before collision is 0. So final we want. Copy it up to A equals to E upon M.
Yeah.
Let tau 1 be relaxation time for an electron accelerated from 0 to V1. Therefore, V1 will be U plus A tau 1. So, V1 is 0 plus A tau 1 equation. Similarly, for n electrons, V2 will be 0 plus A tau 2, V3 is 0 plus A tau 3, dot dot dot, Vn will be 0 plus A tau n. Therefore, V1 plus V2 up to Vn divided by up to Vn is equals to A I'm taking common tau 1 plus tau 2 up to tau n. Therefore, V1 plus V2 up to Vn divided by n is A times tau 1 plus tau 2 dot 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 up to tau n divided by n. Please copy this much. Once you are done, tell me 2 more lines are required.
Yeah, done, sir.
By definition, V1 plus V2 dot up to Vn divided by n is denoted as Vd, which is called drift velocity. Tau 1 plus tau 2 up to tau n divided by n is tau. This is called average relaxation time. We can say therefore drift velocity is a tau. So Vd equals to Ep upon mass into tau. This is expression for drift velocity. So whenever electric field is not applied, drift velocity will be zero. Okay. Completed? Is completed till this?
Yeah, sir.
Note right down. Velocity of randomly moving electrons due to thermal agitation is approximately 10 raised to 5 to 10 raised to 6 meter per second. Drift velocity is approximately 10 raised to minus 4 meter per second. Define mobility of electrons. Define mobility of electrons. Shall I clear this? No.
Yeah.
The practical meaning of mobility is how quickly the electrons can come out when electric field is applied. It is measured in terms of ratio of drift velocity to the field applied. So quickness will depend upon speed, more faster speed, more lesser the time. It is defined as the ratio of drift velocity of electron to the electric field applied across conductor. Electric field applied across conductor. So therefore I can say mobility of electrons denoted by mu is V suffix D upon E. Its SI unit is, see, velocity is meter per second. Electric field is potential per meter. Meter goes up, so it is meter square per second per volt. This is SI. Now write definition of mobility. Completed writing?
No.
Since mobility is drift velocity upon E, drift velocity is A into tau upon E. A is force E upon mass M into tau upon E. So drift velocity, mobility is also E by M into tau. Please write this one. Sometimes they can say which one is correct expression for mobility. It is also E upon tau upon M into tau. next heading. Relation between drift velocity and electric current. Relation between drift velocity and electric current. Current means rate of flow of charge, and drift velocity is average velocity by which electrons are drifted out. So if I consider a conductor of length L, comma, area of cross section A, let n, small n, be number of electrons per unit volume. N is number of electron upon volume. What will be volume of conductor having area A, length L? Yes. What will be volume of conductor whose area is A, length is L? Correct?
I'm not sure.
Huh? What is area of conductor having a conductor having area A, length L, volume of this conductor?
I'm not sure, sir.
Don't say beta. This silly things. Volume is area into length. You are telling I am not sure. I don't understand. Purposely you are telling or what? Area into length is volume. This you don't know.
No, I knew.
You know, na, so say with confidence, let it be wrong. This is geometry, this is not physics. Area into length, isn't it volume?
Yeah.
So that means you are knowing now. Even if you are not sure, if you know something, you tell me. If it's wrong, I will rectify it. Otherwise, your confidence, how it will develop? So volume is area into length. Here n means number of electron upon volume. Volume is area into length. So can I say number of electron will be n into L just by cross multiplication? Aditya?
Yeah, so
Okay. So 90% you know, don't worry about that. I will ask only the thing which I feel you are knowing. NaL, this is number of electron. But what is current formula? It is rate of flow of charge. Charge means number of electron into charge of one electron upon time. Please copy this much. Only copy till I is Q by T, Q is N into electron upon time. That much you write till that. Shall I go ahead?
Yeah.
So n means small n into a into L into E upon time. What is distance upon time called as? What will be distance upon time called as?
Speed.
Speed, okay, correct. If I consider moving all in straight line, also I can say it is velocity. So distance upon time covered for the electron to come out of the conductor can be written as drift velocity. We can denote it by V suffix T. So I is N A drift velocity into E. So I have remembered this connection like this. I is Veena, where V is actually drift velocity. So this is relation between current and drift velocity, I equal to V. Now complete till end. Written? Is completed till last line.
Yeah.
Yeah.
So sometimes they will say obtain relation between current density and drift velocity. So one more line I can say. I upon A is drift velocity into E into N. I upon A means current density, N E into drift velocity. In vector form, J is opposite of E. So we can say minus of NE into drift velocity in vector. Because direction of speed, electron is opposite to that of current. So we can also say J is minus NE of VD in vector form. Complete till this. Today we'll stop here. So today you will study and keep yourself ready for Friday's lecture. Sunday will be only what I teach you on Wednesday and Friday. This whatever you are writing, this is your notes. And
Done, sir.
Pardon me, done? Okay. So Sunday's test, what topic? This plus whatever I do in Friday lecture. And as I told, I will give you 10 solved solution of electrostatic which we have done. If I give you solution, then I will give you some 3 numericals also test on electrostatic from this one. So now you have to study Wednesday's work, Friday's work, 1 to 10 solution if I give you on Friday, because I will write and then I will take photograph of that and send. Aditya, clear everything?
Yeah.
Okay, that's all. We'll meet on Friday with current electricity done further. And regularly study, which you are studying, I know that.